Degree of freedom is defined like this. The least, that means minimum, the least possible number of independent coordinates required to specify the motion of a particle or system of particle completely by taking into account the constraint is called as degree of freedom. That means the least positive number of independent coordinates required to specify the motion of a particle or a system of particle completely by taking into account the constraint is called as degree of freedom. For example, consider the motion of free particle in space. To describe its motion, we need three independent coordinates. To describe the motion of a particle moving freely in the space, we need three independent coordinates like x, y, z. That is the Cartesian coordinates, or r, theta, phi. That is the spherical polar coordinates, or r, theta, z. That is the cylindrical polar coordinate, etc. The particle is free to execute its motion along any one of the axes independently. With change in only one coordinate. In such a case, we can say that degree of freedom is 3, as we cannot express the motion of a particle moving in the space less than 3 coordinates. We require minimum 3 coordinates to express complete motion of the particle. The degree of the freedom is 3. Note that for a system of n particles, free from constraint moving independently of each other has degree of freedom n, as each particle requires 3 coordinates to specify its motion completely. Now we shall define generalized coordinates. Definition of the generalized coordinate is a set of linearly independent variables q1, q2, q3, qn that are used to describe the configuration of the system completely by taking into account the constraint forces acting on it. Is called generalized coordinate. We shall explain this. We know that we shall explain this definition. We know that a system of n particles free from constraint has a 3n degree of freedom. If there exists k holonomic constraint, k holonomic constraint expressed in k equations that is Fi, R1, R2, R3, Rn, T equal to 0 for I equal to 1, 2, 3 up to k. That means F1, R1, R2, R3, Rn, T equal to 0, F2, R1, R2, R3, Rn, T equal to 0, F3, R1, R2, R3, Rn, T equal to 0, and so on, Fk, R1, R2, R3, Rn, T equal to 0. Then 3n coordinates are not all independent, but related by K equation of constraint as described in equation 1. Suppose this is one equation number, this system is 1, then as described constraint is in equation 1. We use this K equation to eliminate K coordinates out of 3n coordinates. Thus, we left only 3n minus k equal to n, suppose, independent coordinates. Independent coordinates. We denote this coordinate Qj, j equal to 1, 2, 3 up to small n, and in this case Q1, Q2, Q3 and Qn are called as generalized coordinates. Generalized coordinates. And this type of system has 3n minus k degree of freedom. Thus, from this we can conclude that number of degree of freedom minus number of constraints equal to number of generalized coordinates. That means to obtain number of generalized coordinate, we have to subtract number of constraints from number of degree of freedom. Note that the generalized coordinates need not be the position coordinate. Which have the dimensions of length, breadth and height, but they may be angles. Charges or momentum of the particle. Note that for holonomic system, the number of generalized coordinates is exactly equal to the number of degree of freedom of the system. In holonomic system, the number of generalized coordinates is equal to the number of degree of freedom of the system. That is, for the system of n particles having k holonomic constant, the total number of generalized coordinate is three n minus k, which is nothing but the degree of freedom, and hence they are strictly independent of each other. Now, for non-holonomic system, the number of generalized coordinates is larger than the number of degree of freedom. If there are k holonomic constant and k dash non-holonomic constant, then the number of degree of freedom of the system, number of degree of freedom of the system is 3n minus k dash. But here the number of generalized coordinate is 3n minus k, which is larger than the degree of freedom. Hence, in this case, These generalized coordinates are called as quasi-generalized coordinates. In holonomic, generalized coordinates. In non-holonomic, the generalized coordinates are called as quasi-generalized coordinates.